Hello, this is another physics video, and today I am going to honor the 50th anniversary special of Doctor Who with the science of weeping angels. You've seen them everywhere. Even non-Doctor Who fans have heard of them. They've been everywhere, from internet memes to even Halloween costumes, believe it or not. And today we're going to take a look at the science of these fantastic creatures. So to start out, let's start with quantum locks. This has been mentioned many times, is that by looking at them, you've put them in a state of quantum lock. And what that really means is, well, basically all quantum particles have a wave-particle duality feature, if you could call it, where basically, to put it simply, all particles are waves until acted upon by photons, upon where their waveform, or a big wave of probability, is acted upon and collapsed into a particle, a single point with definite properties. But the waveform itself does not have definite properties. It's all about probability. So these weeping angels are basically quantum particles, but on a larger scale, and there is only one thing that can do this. Only one quantum particle on this large of a scale. It's called a Bose-Einstein condensate. It's basically these really weird isotopes. So when you cool them down to incredibly freezing cold temperatures, they are basically, they're so slow that relativity acts kind of really strangely on them. Instead of having time slow down, it strangely speeds up for them. And as well, it has a unified quantum state among the whole Bose-Einstein condensate. There are multiple known isotopes that this works on. All of these you see here highlighted. Thank you, Wikipedia, for doing the grunt work. So yeah, these are all Bose-Einstein condensates that we know of, have discovered. There are probably many more, however. There are some implications of this, however. For example, it means that a weeping angel must be made of some of these, one of these in specific, for it to have unified quantum properties like that. In addition, the temperature of a weeping angel is within a few degrees of absolute zero, probably meaning, which has even more implications, such as, for example, that they would be actually really slow. Anything at that speed, if you were to move too quickly, you'd have a drastic change in temperature. So that is one area Doctor Who has lied to you about, is that they do not move at the speed you think they do. You can blink and they'll move, but they will not move that quickly. They'd probably accidentally shatter themselves if they were. So that was kind of a little derp on Doctor Who's side. Also, they'd be probably very difficult to maintain, given that they are at such a cold temperature to maintain in any environment. However, this would be a good excuse to mention things about getting strangely cold. Things like that around weeping angels. Though there are more implications as well, including how they're related to time. As I said, Bose-Einstein condensates are so slowly, relativity acts backwards on them. I'm sure you've heard of the famous, as you approach the speed of light, time slows down. Well, Bose-Einstein condensates are so slow, time actually speeds up somewhat for them. So they are definitely intrinsically related to time. However, I don't think they're anywhere near as related as they suck time streams out of people. Yeah, that pretty much sums up all I have set out. Kind of an interesting episode. It was a fan of Doctor Who, that is. It was actually a really good episode. I loved it. I hope you did too. And I just felt like making this, because I thought about it this morning, and I realized, hey, wait a second. Weeping angels are very sciencey. And so I decided to do a science video about them. And thanks for watching. I'll see y'all next time.